My name is Xuebing Zhou. I'm leading privacy research at the Cyber Privacy and Security Lab of Huawei Technology in Munich. So I will chair the session today. Actually, privacy by design is already introduced in the 90s, but till today, it's still a very hard challenge for every company and how to design a good products regarding privacy aspects. And also in the new General Data Protection Regulation, and they also defined privacy by design as a legal obligation for the data processor and controller. And now I think this is the right moment that we reconsider the meaning of the design in the privacy by design. And I'm very happy today that we have this very experienced panelists, and they can share the experience regarding the legal aspect and usability aspect, and also share their best practice in their research and product development. So now I would like to introduce our panelists. And the lady sitting beside me is Athena Bourka, and she's the expert in the network information security and the data security and standardization from ENISA. And Jonathan Fox is the Director of Strategy Planning and Chief Privacy Office and Security Trust Organization from Cisco US. And Ham van Beek, yes, and he is responsible for the strategy in design and creative technology from the Incredible Machine from Netherlands. And the last panelist is the Amy Elliott, and she's the design innovative expert and design director from the NGO in US and Germany. And then I would like to introduce the moderator of our session, Max von Grafenstein. And he's the one also organized this great session today. And he is the head of the research program, Government of Data-Driven Innovative at the Humboldt Institute for Internet and Society. So now I will hand the sessions to Max. Okay.
So thank you very much, Xuebing, Xuebing, for the introduction. So just in terms of structure and content, how we structured this panel is that we will first give by Athena a very brief overview about the concept of privacy by design as required by Article 25 of the GDPR. And then we will show three examples from the business side how companies are currently trying to really implement data protection principles into the design of their business processes and or data-driven products and services. And at the very end, because we have, above all, the very focus on the usability of privacy by design solutions, we will, with Amy, discuss on a conceptual level again how UX design principles can be used in order to make privacy by design solutions more efficient and effective. So in terms of structure, I will introduce quickly every speaker. After the presentation, I will ask one question just to add another perspective. And after the last presentation by Amy, we will open up the discussion for the audience. So Athena, you are working at the ENISA and actually elaborating there since a couple of years on the concept of privacy by design. And I think for our panel it's very important that you give your specific perspective and how you understand the concept of privacy by design under Article 25 GDPR.
So, like exactly in the design of a building, the sooner we take the decisions about how we want it to be built, the easier it is to implement, and it is exactly at the level of the design, at the level of the plans, where you have all the possibilities to do whatever you like. Of course, taking into account the limitations of the overall ecosystem, let's say, where you're building. So it's exactly the same also with privacy and data protection, also security by design. So we, the sooner we apply the data protection and we implement, we integrate the data protection and privacy requirements into the design of systems and services, the easier it is to make them integral part of the functionality of the tools and services. Now, as it was mentioned before, GDPR for the first time introduces a legal obligation for data protection by design and by default to data controllers. It's the first legal instrument we have in that respect. And in fact, what GDPR says is that the controller needs to implement measures that, that will make the design compliant with the data protection principles. So basically, measures that will implement the data protection principles as these are set out in GDPR. Now, this of course is much more easier in theory than in practice. So, how can we project the law to systems? Again, as I said before, this is not a new discussion. Researchers have been working on this question for several years in the area of privacy enhancing technologies. And looking at the life cycle, let's say, of software design, of hardware design, can we miss the connection of the screen? Okay. Looking at the life cycle of software design or hardware design, we have, let's say, two different parts that we need to take into account. On one hand, it's the what element, so what do we need to implement, how we put that into plans. And on the other hand, it's the how, so what type of technologies do we have in place and how we can make them work for the goals that we want to achieve. And I want to say here that in many cases, and as we have seen also from research at ENISA, we see a lot of emphasis on the what. So what are the goals? And most privacy by design frameworks emphasize the goals, which are based, of course, on the data protection principles, but there is very little about the how. And this is the hard technical questions that in many cases are not really answered. So, at ENISA, as we have done a lot of work in the field. I put here our first report in the field, which has been conducted with very well-known experts in the field, privacy and data protection by design. And here, from this work, I would like to emphasize on two key aspects that I think are very important for the design concept of privacy by design. The first one is about the design strategies. So, once we have the requirements, which we do have them from the regulation, we need to think of how we implement them into our system. So, how to make them find their way from abstract requirements to specific system components. And in this attempt, we have promoted also in previous ENISA's work the concept of the design strategies. And here you can see the key 8 design strategies that we have been looking into: minimize, hide, separate, aggregate, inform, enforce, demonstrate, and control. And all of them, I don't have the time to go into a lot of detail about this. These are strategies which are implemented to specific techniques and need to be finally implemented by specific technologies. But all of them together, and each one of them separately, aim to make the abstract, let's say, principles of data protection more specific, let's say, technique that will finally become, as I said in the beginning, system components. And then, of course, the second essential element is the how, which are the technologies. There are many different privacy enhancing technologies. As I said, there's been research going on this this topic for many years now. At ENISA, we have looked at some of the available technologies in the area that you can see in the slides of authentication and access control, secure private communication, database privacy, privacy-enhancing data mining, storage privacy, privacy-preserving computations, and also the whole area of transparency and control mechanisms, the subject rights, let's say, which is a very important and integral part, and we should never forget about that, of technologies as well that are implemented privacy by design. But then one key question that we have seen in practice, and in many cases we're being asked as well, is again, which tool is better? What should I use? What should I use to become compliant? And what is the state of the art? This is a very difficult question to answer, and I believe that at the end there's not really an answer to this question. There's not one tool, there's not one technology. And that's why we find that it is very important to work towards the idea of providing a PETS repository, which will be able to provide assessment of different types of tools and the possibility for the community to work with these tools. And we have started actually against such an approach, but we think that this should be a community effort, so we think that it's very important to build a community which will support a PETS assessment methodology and the PETS repository available for the developers in the context of privacy by design. Anyway, I'm finishing my presentation. I only wanted to make some final notes, which I think are very important for privacy and data protection by design. So, first of all, exactly like building of the house, as I said already in the beginning, we need to take very well into account the ecosystem into which we are building. This time is in many cases disregarded, and in a recent ENISA report, it's going to be published, very soon, when we try to analyze by design in the area of mobile apps, we saw that maybe one of the main issues in this area is exactly the fact that the way that the ecosystem and the design is working in this field is not appropriately taken into account when we're talking about privacy by design. So we talk a lot about the what, but we do not talk a lot about the how. So I think this is one key element. Then a second important element is that we see also in literature very often that privacy requirements are associated with security requirements. This is right, because security is definitely a very important aspect for achieving privacy, but of course there are many other dimensions that also need to be taken into account, which cover all perspectives of privacy. For example, the whole area of data subject rights, control, and transparency, I mentioned just before, is not about security. Third point, and I think it was already mentioned by our chair in the beginning, usability is a key. We're now in the area of UX designers, and so user needs to be put in the core of the design, but users should not be overloaded. This is again a design decision, it's a very important one, because overloading the user, for example, requiring the user to give consent all the time, is not necessarily the right solution, because it can lead to exactly the opposite effect. It can lead to habituation. And last but not least, I mentioned it before, I really believe that there is a lot of work still to be done in the area of maturity assessment of pets and of community-driven and maintained repository of pets, which should be a continuous exercise and can help developers in all fields support their strategies. So I will close my short presentation with a quote from an important, in my opinion, designer, Steve Jobs, who said that design is not just what it looks like and feels like. Design is how it works. And I believe that this is really very applicable in the case of privacy and data protection. It should be about how it works. It should be about making data protection requirements integral parts of the way that systems and services work. I don't think we're yet there, exactly because of the limitations that I mentioned, but I think that it's a very important, very serious challenge that also GDPR is putting, and perhaps we should see that as an opportunity to further work in this area. Thank you very much.
So thank you very much, Athena. I think you tackled quite a few super interesting topics. I would like to emphasize one aspect, and this is what you mean or mentioned with the terms the maturity assessment. So my question would be so far, just in order to clarify this, do you mean with this, or does your group of people mean that this is something like the assessment for this in relation to the state of the art? Just to bring this back to mind, so the question here is, if a data controller shall, when implementing the data protection principles into the technical and organizational design in its processes, products, etc., it shall take into account the costs and the risks, etc., but also the state of the art. And the big question there, I think, is based on a huge knowledge governance problem, because how shall a little startup based in Barcelona know whether a medium-sized company from Lower Bavaria in Germany has recently pushed the state of the art? And this is a big question, and I think as far as I understood your approach, that this maturity assessment and based on this community, that this is a first idea how this governance, knowledge governance problem could be solved. Is this right?
Yes, I think it's something, actually, I don't know if it would solve the issue. I think the idea is to contribute towards establishing the state of the art. Indeed, it's a very important question. Actually, I had a similar discussion yesterday in the CSA workshop that was taking place here in Brussels, and of course this was in the context of crypto, but it's of course applicable to any other type of technology. Of course, data controllers want to know what is the state of the art, what can I use, and what can make them again compliant with the legal text. I think that there is not one solution to this, and for sure there's not going to be any body that will give solutions marked as GDPR compliant. However, it is very important to establish what is the state of the art in the different types of technologies, being it cryptography, being it other types of technologies such as in the area of anonymization, anonymization techniques, with a repository of tools and the possibility to assess specific characteristics based on a standardized way. This is the approach, it's one idea that we had at ENISA to establish a methodology and say that we'll be able to assess standardized items of the PEC. For example, what is the level of readiness to be adopted by data controllers, what is the level of profession that it offers based on the specific, of course, characteristics that the spec has, specific features. And we think this is, of course, one proposal, maybe many other proposals. I think, as I said at the beginning, this cannot be only an attempt of one institution, of one body. It is a community approach, because there is a lot of work in the field, and we really believe that this should be the future towards establishing the state of the art. Also in, let's say, an interactive and continuous way, because the state of the art is not stable. What is state of the art today is not going to be state of the art necessarily in a few years. So we need to have that as a long-term exercise, as a long-term task.
Yeah, so I see it the same way, but let's discuss this with the audience later on. So let's come to the very first example, to you, Jonathan. So you are working at Cisco, and you are also the co-author of the Privacy Engineers Manifesto, Getting from Policy to Code to QA and to Value. So, and you are trying, or you are implementing since a couple of years, well, the approach of privacy by design at Cisco. Okay, and yeah, we are very excited in hearing from your insights.
Good interface, clear direction on what is forward and what is backward. Let me begin. I'd like to start this discussion with this image of a top spinning. And it's for a good reason. Because as we think about it's a competition to maintain balance across numerous requirements. And since not always one requirement can be fully met, sometimes we have to overcompensate with another requirement to keep balance. So parts engineering requires sensitive products are not retrieved by any one requirement, but across a number of underlying requirements. And with that, I think this is an important point. Privacy engineering is about thinking of privacy as a functional requirement. In engineering, there are two types of requirements: functional requirements, non-functional requirements. Functional requirements you design to, non-functional requirements are attributes of what has been designed. Up until now, too often, privacy, because of its complexity, has been thought of as a non-functional requirement, and a non-functional requirement, a quality attribute. In other words, at the end of the project, we step back and we see whether you achieved it. We advocate something else, that we have to think about privacy as a requirement, and to do that, we have to conceptualize things a little bit differently than just the word privacy. You have to think about it not merely as a system requirement, or a data requirement, or a physics requirement, but you have to think about it as all three. There's a context that has to be maintained. To use an old phrase from the 70s, there's a gestalt that has to be maintained. If you think of privacy as only a business requirement, you're going to fall down in technical implementation. If you think about it as a technical implementation, you're going to fall down because of business and when they will support it. At the end of the day, products are made because people will buy them, and so business decisions drive technical decisions. You also have to think about privacy as a requirement. Too often we think about our privacy notices, our policies, as things to inform users of our products on how they process information, personal information. We have to actually think about our privacy statements and policies as meta-use case documents that dictate and indicate to engineers how they are supposed to design and implement their technologies. And so we have to think about rewriting or writing parallel documents that are easily used by engineers so that they can fill their product requirements documents, their agile stories with use cases that support privacy so it can be designed. We also have to think about privacy as not merely the one word privacy. We have to think about it as the underlying requirements of understanding your data. And this is where I'm going to have to stretch my house. Of purpose. How is the data going to be used? You have to think of all the different requirements that are embodied in various iterations of the test and break them down into components that engineers can design to. To just say, be privacy sensitive is too big a concept. You have to tear it down into things that can actually be coded and engineered for us, and policies and programs and processes take place where technology won't support. I will reveal a personal fact you cannot see very well. You have to think education as a means of collection. You have to understand what is a legitimate basis for processing. You have to organize thoughts about transfer, and so on. I'm not going to go through this whole list because time is limited. Oops, went too far. So at the onset of the design process, you have to think about what are the goals of the enterprise status which is being designed. You have to think about the policy, and I'm not referring merely to the meta policy that every enterprise has, but what is the specific policy and what is being created. You have to then factor that down into requirements that can be coded to it. And then you have to decide which are going to be handled as procedures and processes, and which will be handled by technologies, and then which will be handled by privacy-enhancing technologies. And then you build awareness and educate your team, your engineers, on the processes, and your enterprise. You have to think of it through a slightly different viewfinder than we have traditionally thought about things. You have to think of it, we talk a lot about the Internet of things. We have to talk about the Internet of everything, because everything is increasingly connected. We We also have to talk about the Internet of Ethics, because we have to look at how we're processing personal information through an ethical viewfinder. And then you have to also think about it through the viewfinder of the Internet experience, because ultimately privacy becomes a user experience issue. A design issue, we have large design issue, in specific to a product or system, and then you have to think whole product, because you need to better inform consumers and users of products well before they engage. The mode of communication in privacy design is not when they log in or when they accept terms of use in the privacy notes. It should be all the way from the documentation and descriptions of the product and purpose. And so we have to really think across the perspective. As I mentioned earlier, we have to think whole business. This is a matter of applying business strategy to business results and enterprise architecture. To truly do privacy by design, truly privacy engineering, you have to think not only in terms of engineering your systems and your processes, but you have to think in terms of engineering your enterprise. Because the obligations to privacy in a system or product do not end with that product itself. It takes alignment across the enterprise. There needs to be data governance, there needs to be coordination of security, data architectures, IT, data stewards, and business teams. It all fits together. Privacy engineering does not happen alone in the technical space. It is a cross-enterprise obligation. Many people ask me, what is the difference between privacy by design and privacy engineering? Privacy design, as I think it described it, is that decision to design, how the goals, how to design the overall plan. Privacy engineering is the next step down, actually how to use those technologies, how to put them together, how to communicate to engineers, and how to build it actually at a technical level into a system, into a product, into an application. They're highly compatible and one leads to the other, you don't have to happen without the other. So as an example of privacy engineering, I'm going to talk about Meraki, which is a cloud-based network management product Cisco produces. It achieved privacy, 2 minutes? It achieved privacy design from a very specific purpose and a user-centric design. First, the Meraki team founded the concept of the clean notion of, and I have this written down so I get it right, networks that simply work. That was the goal, that was the mission. To make the network, the work of network engineers simple and not suck up lots of data for other purposes. So from the very design concept, from the very conception of the Meraki network management product, we had introduced notions of limitation, of purpose, and of data minimization. And it was through this process that the Meraki team achieved privacy by design and the implementation of their tool set. And I'll quickly go through a couple examples. So, let's just skip ahead. So, out-of-band architecture. It was basically designed so that only network management data went to the Meraki cloud. Actual content that traffic on the network never went to the cloud, stayed in the network, stayed with the enterprise. There's a single pane, so the only to access the network administrators had was the data that was collected from a single pane, so there's complete transparency and the visibility in the type of data that was collected. Meraki was also designed with 2 data subjects in mind. One was the network administrator, and one was the end user whose network, who would be attaching to the network for the wireless services. So that enabled, Meraki decided to enable a customized splash page, so when users connected to the network, the customer who wanted to promote and supply the network, customize the messaging and provide their own message and link to their own policies, and so that it whose data and who the data controller was. Network data minimization, I mentioned this earlier, the architecture, which will enable data traffic, data privacy-sensitive packet capture. By reducing the number and duration of packet capture, they turn packet capture into strictly and for that to be used for diagnostic and troubleshooting and not other purposes. Security, the network through security and the dashboard, auditable, role-based authentication, passwords, all state-of-the-art, leading-edge security practices, and then the data center ISO certification, SAS certifications, and SAF 16 certifications, so security is highly prized. 1 minute?
30 seconds.
30 seconds? Okay, so here's what's really interesting about Meraki. Meraki also enables networks to manage video, but the video never leaves the network, never comes back to the cloud. It's downloaded directly onto the administrator's browsers or desktops. And the same with location analytics. If a user does not attach to the network, the IP address and MAC address in their system never goes back to the Meraki cloud. And when they attach to the network, it's encrypted with one-way hashes, salted, and then truncated to reduce re-identification virtually impossible. So Meraki achieved privacy engineering or privacy by design through user-centric design, through desire to think in terms of what the customer needed and what the end user wished, and to stay true to their purpose of making network management simple and not for other purposes. Thank you.
So thank you very much, Jonathan. I understand your presentation. Well, I see there are two parts actually. So the first part was more tackling a general methodology in helping you and your colleagues when implementing your privacy engineering approach in your company, making them match with the already ongoing business processes, and then you showed an example. So let's match this together again, and I have just one specific question. So if you remember, or when you were talking in the last couple of weeks with the developers who designed this product, the Meraki line, so what do you think were the biggest challenges when trying to or implementing privacy by design?
Well, I think first is a language issue. Engineers think differently, talk differently, problem solve differently than legal and compliance people. We've been using the term privacy when we really meant minimization, deletion, access, proportionality, security. We give the engineers those things. They can design for those. Two, it's a new skill set. Engineers have not been taught it. This is something that's been taught hostage by legal compliance. We need to free it from those boundaries. And four, it's really, as I think Athena highlighted, an interdisciplinary topic.
And how do you address this?
Well, communication across boundaries, training. But you have to think of your privacy assessment, your privacy reviews as both a report and a tool for communication. The privacy assessment should begin at the very inception of the product and then travel the whole life cycle of development. So what's being decided by an engineer can be communicated to the user experience team, can be communicated to the operations team, can be coded and managed in the back end. Where I've lost the most time doing my privacy reviews is the person who's managing the back end has a completely different concept of what the data is than the person who's deciding deployment. And getting those two to agree is often the biggest challenge.
Okay. Yeah, thank you, Jonathan, for your insights. Let's go quickly or directly to Katrin from the German Bundesdruckerei. So for everybody who doesn't speak German, so the Bundesdruckerei, actually, they print the money. They are doing or making the ID cards, and so naturally or historically the German Bundesdruckerei has always dealt since decades with security issues at least, And as far as I understood you, I think that the Bundesdruckerei has discovered now this new privacy and security by design approach as required by law through the GDPR as a huge business opportunity. And so let's go into these details. And I'm very excited about your example, because I think you have developed a user-centric, a very usable identity management solution based on blockchain.
Our main goal of Fides is to give the user self-determination about their data and their own identity. So in our system, everyone is responsible for their own data. There's no need for a superior administrator who has access to everything. So each user stays the master of his own data. To make Fides even more secure, we developed a new form of blockchain, which we call a keychain. You can imagine keychains are short blockchains and a private version of the blockchain. That means that we do not create one big chain for the whole system. We create multiple shorter keychains for each identity and each permission. So as a user, you can only see keychains that belong to your identity and your data. So it's private. You can imagine keychains also as some kind of a timeline that shows the user who did when and with which permission uses his data or accesses information. So everything is traceable for the user. We also really focus on creating a very flexible identity management to handle any kind of identities and their features in a company. So it can handle identities for persons, objects, and also processes. No matter how complex or new the technology we are using, we also make sure to cooperate to make the user the key factor when we are developing. So to make Fides an even more easy to use solution, we combine it with our new employee ID card, the GoID card. Here we use the GoID card for secure login. The great thing is we integrate a fingerprint scanner with the card for an easy and fast authentication of the user. And now the privacy by design approach. All the biometric data is only stored and processed within the card. No information is given to a background system. So the user stays always in charge of his own information. So how did we create Fides? With Fides we tried a totally new approach. We first defined the interface for the user and then started the software development behind the interface. Of course, first we defined what do we want to create, but very briefly. We only defined we want to manage identities and we want to manage permissions. Then we started a design contest. By giving the designers such a minimalistic briefing, and they were able to deal with identities and permissions from their own perspective, without being influenced by our technical point of view. At the end, we choose a designer who uses the gamification principle to design the
Okay, I hope the technology will play with and we can show the system outside of Germany because it's secured. And here you can see the screen. Here is our fingerprint card. Here is the fingerprint sensor. Those of you who would like to see it closer, you can ask me later. So, and the idea is behind there is a security chip, antenna that allowed to work with this card contactless. And it will provide security information from the security chip only when your fingerprint is on the card. In other cases, it's absolutely secure. So I put the card on card reader. So this is IP address of our identity management system. I'm asked now to provide a fingerprint. I put my finger on, certificated thread. So now we are in the system. So now the system built all the rights that I have in my company. So here, without any filtering, you'll see all the rights that I have in my company, including accesses to the certain doors, to the servers, file systems, databases, and project information. So we have designed a Windows menu for those who like Windows style. For other people who plays with iPads and Mac, it's better to use another menu like this one. There are not so many operations here. It's user-friendly. You can just create a new permission, edit permission, delegate permission, revoke permission, and some of you who are in advanced position will be able to add a new identity into the system and edit this identity. As Katrin told already, we don't just differentiate between person, object, and process. They are all identities for us, and we will will handle with them on the similar way. So then we will try to do simple operations. For example, here we have a door control of our innovation door, and on the left side, I always see from whom I got this permission. We'll see that Herr Hamann gave me this permission and Mr. Peschke got this permission and delegated to me. And I was so trustful that I have delegated this permission to enter this door to other workers in our company. Here you can see also some names. I should play with the resolution because resolution of this display is not so good. On the screen it looks a little bit better. So here you can also choose a person and you see at one time all permissions that this person got from me, all at once. You can choose also person and see who is it, who got this permission from me. And here we have not defined then fields. You can define freely what you would like to see to this person. So we will try to make a simple operation. I have seen, for example, that Mr. Kraus is not in our company anymore or not in my department, and I would like to revoke from him the right to access the system. Simple step, and now he doesn't have the right to access the system anymore. So update of the system, and on the same way I see further delegation of my right. For example, I have delegated access. It's better not to take access. We have a project blockchain in the company, and I'm in the lead of this project. And I have delegated the rights to some people here, here, and here. So, and Mr. Wilke, for example, he has delegated this right further. I can follow the way. This means till the last person, to the last identity, I can follow and look who has access to my data, to my project. And if I don't like him, for example, I see that Andreas Wilke have delegated to Florian Martin, and Martin Florian has delegated to some unknown to me person, and I don't trust this person, even it's some levels below me. So I just tell revocate this right.
Okay.
It's my data, I control it. Okay, one more step. I just show you how to delegate the right to the person. In this case, I delegate the right to access the room. Bella Livia, for example, it could be delegator or person will just have this permission. We can set to one it is valid. I delegate it. and now this person has this delegation. One more stuff, very shortly. We have here a real blockchain that make a protocol of all actions that happens to my identity. I got permission, I delegated permission, permission was revoked from me. And I can follow this timeline till the very beginning. This is the day of the birth of my identity in the system. Here, for example, I've got already some permissions and delegated it further. You can download this blockchain. If you don't trust this system, you can download this blockchain. Months later, come again to the system, download this blockchain again, go to Ethereum or another Hyperledger, another authority, and check these two blockchains against each other to see that you can trust the system is still stable. Okay, thank you.
Okay, super. So just to make it clear, I imagine that you could use this technology, for example, for public administration. So I go as a citizen to, I don't know, to the public agency in order to register my car license plate number or to get it. And then I have an interface there and I can exactly determine who in this state organizational complex gets the access rights and to what kind of data and for what purposes. Is this correct?
Yes, that's correct. You can always find out who has permission from you, which kind of permission has you, and it's the whole organization around, it's independent from the level. You can use it for private organization, for governmental, and for private individual as clients by government. In this case, you will even delegate the rights, the government, to see your personal data. You always have full control over your data.
So just a quick question, a quick one to Katrin. So if you look at this designed visual interface, so what would you say was the biggest challenge when implementing using UX design principles in order to implement privacy by design solutions? Okay, so thank you. So let's come to the last example before we discuss again on a more conceptual, abstract level how to use UX design principles for implementing privacy by design. So let's come to Harm and his incredible transparency making machine. So actually, this is an e-charging station, and the background story for that is that there are actually only you have only 3 plug-ins, so there can only 3 cars filled up with electricity. And the problem was, what the grid operator has seen, that actually there is a potential that there are potentially discriminatory effects, because sometimes different cars get more electricity or quicker electricity than the others. For example, if you have an emergency call and you are a doctor, or if you are a notary, or if you only have a very urgent family thing and you only need quick, just little electricity, etc., etc. And instead of solving this, this question alone, the idea was behind that to make just the functioning of this algorithm transparent so that the users of this e-charging machine could discuss it on their own. Of course, you can now ask whether this is a privacy by design solution. I think yes, because you need your identity or credit card in order to pay, so everything is identifiable, at least, I would say. But even if you are not agree with this narrow understanding of data protection laws, you could take this just as an inspiring example how you can make these UX and privacy by design mechanisms implementing the principle of fairness and transparency into a real tangible product. So this was just a larger introduction. Yeah, sorry.
Maybe if we switch to my presentation, I'll do like a short introduction also so people know who's talking to them. So I'm a designer with Incredible Machine. Incredible Machine is a small design agency from just do the slides from the top of my head. What we do is we help organizations, commercial and non-commercial, to try and come up with new concepts and make a positive impact in the world, and usually this has to do a lot with new technology. We are what we call a boutique strategic design lab. That means as much that we are actually a very small company. It's just myself and my colleague Marcel. So we're basically two guys, sort of large organization, but we tend to scale up a lot with sort of freelancers when we have larger projects. And we've been working together now for about 5 years. We've done loads of work for sort of large corporations, looking to implement new technology. And we used to do it as sort of like traditional designers, just make a cool prototype and come up with a concept. And that was that. But actually, recently, we are more involved with the ethical side of things. We started off with lots of work in IT, and we were co-authors of the IT Design Manifesto. There's loads of manifestos currently being written about how we should take ethics into consideration when we talk about design and technology. Well, we were also one of them. This is really geared towards the design communities, anyone who's an engineer or developer or designer working on IT. 10 principles that we thought were important to think about when you're doing this. And of course, privacy and security are a major practice in that, but also giving users control over their own data and so on. If you want to know more about this, you can go to iotmanifesto.org and read all about it. This was also a changing point in our business, and it's quite important to be here, where we now are trying to focus more on, as a designer, to take responsibility and have the right design decisions from the start. And that's also sort of the project that we're going to talk about. Really started where a client came to us with that particular question, which is relatively new for us as well. So as Max already said, we're going to move a little away maybe from strict privacy by design. We're going to talk about algorithms and accountability in the smart city. The way we see a smart city is, basically it's about the allocation of resources. And most of the time the cities are semi-public resources. So it can be regulated parking, things like noise, traffic, public transport, and so on. The list goes on. To just take an example of parking, that really shows you how complicated it can be on how to make decisions. Because basically what the smart city will probably do is actually make these decisions algorithmically. So the first picture that you saw where a man in a suit was touching a piece of glass, it's probably not going to be a reality. It's going to be sort of automated, right? So let's say there's a parking spot. How does the algorithm know what to do? Well, maybe one car came first. It just needs to be there for a short time. The other cars, maybe zero emission cars. So how do you then sort of make that trade-off? Which one gets the part first? Well, this is actually something, if you have these algorithms running in a smart city, are these algorithms actually fair? And how can we know about this? So this is more sort of the theoretical background, but we actually have a clear case where this is already becoming an issue in smart charging. So we were commissioned by grid operator in Holland, is also sort of working on charging points. And the problem is, if you want to charge one electric car, there's the same amount as 5 households. So if everybody comes home around 6 o'clock and there's a row of Teslas that need to be charged, the power grid can never deal with it, because it wasn't designed for that. So the problem is, either you install a new grid, which of course will cost you, but will never happen, or you use smart charging. So smart charging means basically some cars get charged first, others charge later. How do you decide it? Well, also these kind of data points. So stage is our solution to this. So we built a prototype and I'm going to demonstrate to you. I'm going to go over to grab the mic. All right. So this prototype, maybe to explain a little bit to you, here we have sort of the usual plugs for your cars. We have a red position, a green position, and a blue position. Here we have the interface for the users to interact with, and here we have an extra piece that we added, which we call the Tetris. And basically what it is, it shows you a prognosis of how much power there will be available in the grid. So going up, that's sort of like the future, and actually you see that there's sometimes it's a bit wider, sometimes it's a bit more narrow. That means, you know, if the wind is expected to blow, there will probably be more renewable energy. If there's more households requiring power, we'll have a little bit less. So this is actually what the grid can actually give you. Right, so now I'm going to pretend that I'm going to charge my car. I don't have a car, but I do have a cable. So I'm going to plug in. Now the interface is asking me to present my card. And actually my card, this is my identity for now. So I am a membership of a car share. And I have a couple of things that say something about the priority I have with charging. I'm going to tap my card here. Now you just see that the red dots are all the charge that I am sort of taking away from this particular position. I can change here a little bit, saying maybe I want a little bit more. So I turn this knob to get more. I can change my deadline here. Oh, I won't make it, right? Okay, so now I can actually just leave and let my car charge. But, of course, then someone else comes, plugs in, and let's say I have a different personality now. I'm a medical doctor, so I have that card here. I'm going to tap my card. Okay, now we see something interesting. Actually, the medical doctor is pushing me all the way up, and if I need a little bit more, maybe all the way to a point where I can now see that I'm actually here. It says that the car share person cannot charge before the deadline. So now we see that there's friction. It doesn't really tell you why the algorithm does this. Because when we were designing this thing, we figured out actually no one's really interested in exactly what the algorithm is thinking. You just want to know, will I be charged or not? And you want to have a little bit of information about why actually I now, as the car share person, am getting less charged. And see, okay, there's a medical doctor. Maybe I think it's okay. Maybe I think it's okay that I don't get so much charge, and because the doctor might be on call for emergencies. So the idea is actually that we're providing some form of transparency. I can maybe, since we're in Brussels, add another one. Let's say that I'm a diplomat. Maybe in Brussels it can be a big problem. That one charges. Okay. Actually, the diplomat almost has sort of the same rights as the doctor, but you can see now both the doctor and the car share person cannot charge. So there's one last thing that actually, yeah, good. There's one last thing that you can do. So say that I want to leave as the car share person. Then it asks me, was your charge action fair? And if I tap my card again, it will actually give me a replay of the whole charge action because I wasn't there. So see, okay, I arrived. Maybe I missed a little bit with the amount of charge that I wanted. Then the medical doctor comes. Maybe that one turn a little bit. So actually this can be seen as sort of like a receipt of your charge action. And the idea is actually that this makes it possible to then go and talk about this with your charge point operator or with your city hall, saying actually the way this algorithm works, I don't know exactly how it works, but I'm pretty sure that this is not what I would want, and then we can do something about it. Okay. Moving on to the last two slides, which actually is quite important.
So okay, because I have to make the bridge now to a.
Okay, yeah.
But okay.
Sure.
So, because I really think that, I mean, we got the functioning of this UX design, etc. And I think it's a brilliant example how to make data protection principles like fairness and transparency tangible. So in a way, so that the users can really understand what this algorithm is about. So now let's go back again on a more abstract level, and let's discuss with Amy. On the more general question, how UX design principles could be used for implementing privacy by design.
Hello everyone, I'm Elliott with Simply Secure. I'm going to give you an express overview. There's too much content to fit into the very limited minutes that we have, but I'm here today and tomorrow, and I invite you to reach out and ask me questions. I'm happy to discuss this further. I'm with Simply Secure, an American nonprofit that educates designers, technologists, researchers on questions of security, privacy, transparency, and ethics. So, of these points, I'm going to jump into the everyday examples, how we see these principles playing out today now on the screen. So, user experience design is a craft or a practice for creating digital experiences. And it's not actually new. So if you consider Vitruvius, the time of ancient Greece, architectural knowledge, there's a clear intellectual through line in terms of how people interact with their environment. This isn't something that's a recent development. In the United States, my home country, Harvard University grants doctorates in design. There's a robust history of thinking there. And one of the key points I'd like to make is it shouldn't only be policymakers and technologists that design implementation details matter. So in terms of icons, user experience design right now, the mobile phone has changed a lot about computing. My own work considers questions of the Internet of Things from a privacy and consent lens. Getting consent on a mobile device is tricky, and I'm going to show some examples that I think work well and are less successful. User experience design in practice. Thank you. An elegant example are the check marks on your red receipts for messaging. That shapes behavior. If I get a WhatsApp message like you see on the right and there's a check, I know someone has read it. No matter what cell phone provider are they on the Wi-Fi, when I get that alert or notification, I change my behavior in that I don't touch my phone. I don't want to be rude and have that check mark next to my name because then it's my fault for not being quicker to respond. That is a UX design decision. If the people that developed the system made a different choice, let's say a new law requires red receipts. Every messaging app must issue red receipts. There is no precedent that I know of for the implementation details on the UX side. If the way that you see a red receipt instead of a check mark or notification on the home screen is to do a long press on the user's name, see a drop-down menu of message IDs, type in message 00563, and then get an answer of message status equals 0 or message status equals 1. That may be a red receipt. the rate at which people will be required to manage these notifications does not scale. There's no way to do that. So if we have the opportunity to see even 5 seconds of this video, I think it would be helpful. Okay. I guess we will call that a no, and I will move on.
But you... I mean, I could also fill...
I would like to just leave it on the commercial page because it's simply secure knowledge base, but I'm not able to advance the slides any longer. So if someone could at least advance to the last slide, I would appreciate that.
There we are.
Okay, all right, let's see if I can keep it moving. All right, there are more examples. We have a set of articles that deal with these topics, targeting designers, technologists, researchers, and others. As a nonprofit, we work for you, so I welcome your feedback on how to improve that and make it better. This is my contact information. Nope, not going to happen. Just approach me. I'm Elliott with Simply Secure. I welcome a chance to discuss this further.
Let me ask one last question, because I think this is so highly important in your presentation and we skipped that. So, I mean, how to measure the effectiveness and efficiency of these UX-based privacy by design measures. And you just had this example with the Google HTTPS icons, and maybe you could just end with this last remark, how this could be used.
So there's some interesting work that the Google Chrome team has done on security indicators in the browser about how HTTP is their
So thank you so much for making this very important point, because this can be combined with the state-of-the-art assessment, because if we are talking about the state-of-the-art, it's all about measurement. So let's skip, I'm so sorry about this, shame on me, the questions from the audience now to the lunch. We are still here, and just come to us if there should be further questions. Thank you so much for being here.